Bismillahirrahmanirrahim. This is unit number 14, current electricity conceptual questions, physics 10, National Book Foundation. Question 1. Can current flow through a circuit without potential difference? Now, the answer to this is no, the current cannot flow through a circuit without potential difference. The current in a circuit is defined through the Ohm's law, which states that a current I flowing through a conductor is directly proportional to the potential difference V applied across its ends, provided that physical conditions such as temperature, etc. are kept constant. So mathematically it can be expressed as current I is directly proportional to V, or I is equal to V over R, where R is the constant of proportionality. Now it can be seen mathematically that current I depends on the potential difference V. If V is equal to 0, the potential difference is equal to 0, then the current is also 0. Question 2. If aluminum and copper wires of same length have the same resistance, which wire has a larger diameter? Now the key point here is the factors affecting the resistance of the conductors are length L, cross-sectional area A, and the resistivity of the material, that is of aluminum or copper. That means R is equal to rho, the resistivity, length divided by A. That means more length, more resistance, more area, less resistance. Since it is required to compare the diameter of the two conductors, copper and aluminum, and it is the area of the wires which depends on the diameter of the wires, hence writing the equation for area A. I'll write this equation for area A, moving area A to the left hand side and R to the right hand side will make it A is equal to resistivity rho L divided by R. So area depends on more area, more length, and more resistance, less area. Since in this case, for length L and the resistance R being same, the area solely depends on the resistivity rho, because in the case of aluminum and the copper wires, length and resistance are same, so area only depends on the resistivity. Whatever material has more resistivity will have more area as well. That means area A is equal to pi r square of the wire solely depends on the diameter or radius of the wire. The resistivity of aluminum is more than that of copper, and the aluminum wire would have larger diameter than copper to have the same resistance for same length. Question number 3. What is the resistance across open switch and closed switch of a circuit? Now this is an open circuit. This is a circuit showing two resistors, one battery, and this is an open switch, whereas this one is a closed circuit, a battery, same two resistors, and this switch is closed here. Now, resistance across an open switch circuit is considered as infinite. The resistance is infinite, which does not allow any current to pass through the circuit. Whereas resistance across a closed switch considered as zero resistance, which allows maximum current to pass through the resistance. Since there is no resistance here through the switch, so maximum current will pass through the circuit. Question number 4. why a bird sitting on a high voltage transmission line is not electrocuted. However, if it tries to fly away and touches another bird sitting on the other transmission line, gets heavily electrocuted, why? The answer is, when a bird sits on a high voltage transmission line, it does not complete the circuit, since it does not touch any part of the other transmission line or the neutral line. Since the circuit is not complete, no current passes through the bird. However, if in an attempt to fly away, when it opens up its wings and touches the other bird sitting on the other line, or any part of its wing touches the other line itself, it will get electrocuted along with the other bird as well, because it completes the path for the electric current to pass through the bird. Now, question number 5. You are given 5 resistances of different magnitudes and you are asked to form a circuit using all 5 such that the net resistance of the circuit is less than any of the given resistances. Now, the key point here is, in parallel combination of the resistances, the net resistance of the circuit is always less than any of the resistors used in the circuit. Now, this is a parallel circuit. There are 5 resistors R1, R2, R3, R4 and R5 connected with this battery. These are all 5 paths. If I add another path for that matter, it will provide an additional path for the current, hence reducing the overall resistance and giving another path to the current. So what I mean to say here is, parallel combination of resistors always reduces the net resistance. And for 5 given resistances, the equivalent resistance is calculated as 1 over R equivalent is equal to 1 over R1 plus 1 over R2 plus 1 over R3 plus 1 over R4 plus 1 over R5. Now here, in order to make this comparison and to see what happens when 5 different resistances are connected, we take arbitrarily select some resistances, all of different ohmage, and let those 5 resistances be R1 equal to 2 ohm, R2 is equal to 3 ohm, R3 is equal to 4 ohm, R4 is equal to 6 ohm, and R5 is equal to 12 ohm. I have chosen these all different resistances considering easy calculations, so that these calculations, once I perform here, become easier. We may not have to use the calculator even to make these calculations. I have chosen this maximum resistance of 12 ohm such that I have this 12 ohm and then 4 other resistances such that all these are factors of 12. 2 is a factor of 12, 3 is a factor of 12, 4 is a factor of 12, and 6 is also a factor of 12. That means 12 is the least common multiple, LCM, of all these 4 resistors below it. So what I write is 1 over R equivalent is equal to 1 over 2 plus 1 over 3 plus 1 over 4 plus 1 over 6 plus 1 over 12. Now, this is the parallel circuit, and the resistors that I chose are 1 over R equivalent is equal to 1 over 2 plus 1 over 3 plus 1 over 4 plus 1 over 6 plus 1 over 12. As I told you that I have chosen them such that the maximum resistance of 12 is the least common multiple of all these lower resistors. So I write 12 as the LCM, and then I write 6 here, 4 here, 3 here, 2 here, 1, as we do add the fractions, and the sum of all these gives me 6 plus 4, 10, 13, 15, and 1, 16 over 12. This is 1 over R equivalent is equal to 16 over 12. I reduce this fraction to 4 over 3, and then when I write R equivalent, I take the reciprocal of this 3 over 4, and 3 over 4 you know is equal to 0.75 ohms. So my net resistance is 0.75 ohm. My question was that I need to connect them in a circuit so that my resultant resistance is even less than any of these. My minimum resistance was 2. My resultant here equivalent resistance is 0.75 ohm. I have chosen all these 5 with these numbers to make my calculation easier. I can suggest you to use a resistance of 4 ohm, 6 ohm, 8 ohm, 12 ohm and 24 ohm. Remember here 24 is the least common multiple of all these 4. Or you can also use 8 ohm, 12 ohm, 16 ohm, 24 ohm or 48 ohm. Here 48 will be the LCM. You can try these, even you will maybe getting even better calculations without the use of any calculator. Now, question number 6. You are given n wires, each of resistance R. What is the ratio of maximum to minimum resistance obtainable from these wires? Now, the key point here is, in parallel combination of resistances, the net resistance of the circuit is always less than any of the resistors used. And in series combination of the net resistance of the circuit is the sum of all the resistors involved. Now notice from the key point above, the maximum can be achieved in series combination by adding all the given resistors. On the other hand, in parallel combination, the net resistance is always less than any of the given resistors. So connecting n resistors, each of resistors R in series combination will give R max, R plus R plus R plus R up to goes n times R. So the R max will be n times R. There are n resistors. Similarly, connecting n resistors, each of resistors R in parallel combination gives the minimum, as 1 over R minimum will be equal to 1 over R plus 1 over R plus 1 over R. This will result in n over R, and R minimum will result in R over n. So now again, I'll writing those maximum resistance connecting in resistors in series will give me R max is equal to n over R. Similarly, R min becomes R over n. And when I write the ratio R max to R min, like this is what I am required to produce, what is the ratio of maximum to minimum resistance obtainable from these wires. This is R max to R min. I have calculated R max as NR, and I have calculated R min as R over n. Substituting these values, I get NR ratio R over n. Now, if I multiply both sides with n to get rid of this n in the denominator, I multiply this n here and I multiply this n here. I cut these two n's with each other. So I get n square R ratio R. Again, I can reduce these r's by dividing both sides with R. I get n square ratio 1. So my ratio to maximum to the minimum resistance obtainable from these wires is n square ratio 1. Now remember and note that the maximum to minimum ratio is independent of the value of the resistors. I said maximum to minimum ratio is independent of the value of resistors. It only depends how many resistors are there. So if there are 2 resistors, the ratio will be 4 ratio 1. If there are 3 resistors, it is 9 ratio 1. If there are 4 resistors, 16 ratio 1. 6 is 36 ratio 1. If there are 10 resistors, it will be 100 ratio 1.